Good morning, my dear children. Today we can discuss 11th chemistry, unit number 1, basic concept of chemistry and chemical calculation. That lesson we have to discuss now some of the important question, that is book back question. Some questions are reduced to question, that is page number 33, question number 26, 31, 32, 34, 37, 41, 44 and 45. These are some very important questions, but some of this area are reduced. Especially for the question number 31, you have to learn thoroughly the molecular mass of some compounds. Is very important. Some one words. So that question also I am selecting now, that you must learn some molar mass of some compounds. Okay. Now I am selecting the question number 42. 42, 43, some question we can be discussed now. First one is question number 42. Calculate the empirical and molecular formula of a compound containing 76.6% carbon, 6.38% hydrogen, and rest oxygen. Its vapor density is 47. Calculate the empirical and molecular formula of compound containing 76.6% carbon, 6.38% hydrogen, and the rest remaining is oxygen, and also its vapor density is 47. This is a question. So before that, we have to make one tabular column. We have to calculate the empirical and molecular formula. For finding the empirical formula, we have to make one tabular column. Here, 3 element is given. 3 element percentage is given. How much percentage? For example, carbon, hydrogen, and oxygen. 3 elements. First, I am taking one tabular column. So one first column I am writing element carbon. C means carbon, hydrogen H, and oxygen O, the symbol. Next, the given percentage, carbon percentage is 76.6, hydrogen 6.38, and the rest, that is remaining, is oxygen. Am I right? Here, out of the 100%, that is 76.6 carbon, 6.38 hydrogen. Just we are adding. What's the total? 8, 9, 6 plus 6, 12, 1, 8. So that is carbon and hydrogen total percentage is 82.98. Am I right? Next, remaining rest is on oxygen. Just we are in 100% subtracting, we get the remaining. So 100 minus 82.98. Am I right? Here, what's the answer? Taking 82002 point here 7. Okay, so oxygen percentage is 17.02. Am I right? Next column, atomic mass. Atomic mass, my dear children, already I tell you that we must buy one logarithm table, class table like that, logarithm table. The cost of the table is 20 rupees like that. It is available in our all local bookshop. Those who need now, you have to buy now. In the center of that middle page, the logarithm book, you have the periodic classification table. I think that the page number is 56. We know this is the logarithm table. Am I right? Here page number 54, the periodic classification. Here, this book is permit to write. This book is, we can be permit to the examination hall also. So don't worry that. If it is a new book, we can be take it. Okay. So in the middle page, periodic classification, elements are arranged, am I right? Here, atomic number. But we are expecting the atomic mass. So atomic mass is not here having. So I think that the page number 56, those who have the class table, we take now. They are having some atomic mass, some elements. So carbon is page number, I think that 56. Atomic number is given last here, carbon 6. Atomic mass is 12.01. So just to round up now, we get the 12. We can be approximately right. 12. Am I right? All of you know that one. The atomic number of carbon is 6. So the atomic mass, just to double na 6, double na 12. Am I right? So that also we can be remember 12. And about the hydrogen, all of you know that one. Atomic mass is 1. And about the oxygen atomic number, all of you know, 8 is the atomic number. So just we are double na. That is an 16 like that. Atomic mass is 16. And also sometimes it may be a small variation. Some changes like that. A small minute variation. So just if you are looking right now, it is very simple. Okay. Oxygen. Page number 58. Please turn over the page number 58. Oxygen. Okay, here the middle page. Atomic mass is 16.00 like that. So we can write on a 16. Okay. Next, the third is over. Next one is the fourth column. Relative number of an atom. Okay, relative number of an atom. Relative number of atoms. Here, how will you write the relative number of atoms? Percentage divided by atomic mass. Okay, what is the percentage given in the carbon? Percentage given in the carbon is how much? 76.6. Am I right? Divided by, what is the atomic mass of carbon? 12. So 76.6 divided by 12. Just we are dividing. Please divide and say the answer. Approximately that is equal to 6.38. 6.38. Like that, hydrogen relative number of atoms. How will you write? Percentage divided by atomic mass. So what is the percentage is given? 6.38. This is the percentage of hydrogen divided by atomic mass of hydrogen is equal to 1. So we can be written as 6.38. That also 6.38. Next, oxygen, the relative number of atoms, that is a percentage. Our calculated percentage is 17.02. What's the value? 17.02 divided by atomic mass of oxygen is equal to 16. So 17.02 divided by 16. That also we get the approximately value is 1.06. 1.06. So we have to, next step, we have to take the symbol ratio. The symbol ratio. The next column is symbol ratio. Here the symbol ratio. What is the relative number of atoms for carbon? That is 6.38. Out of this value, relative number of atoms, the value, which one is the least value? Least. Okay, that is 1.06. Am I right? Because the carbon 6.38. Hydrogen is also 6.38. But the oxygen is about 1.06. So I am taking 1.06, the low value, 1.06. So first symbol ratio, whenever we are writing on symbol ratio, you write the first one value 6.38 divided by the least small value 1.06. Just we are dividing, we get approximately our value is equal to 6. Okay, 6 for carbon. Next, about hydrogen is also same like that. Relative number of an atom's value is 6.38 divided by the lowest value, that is 1.06. That is also approximately we get 6. Next, about the oxygen, the relative number of atoms is 1.06, am I right? Divided by the least value is 1.06, that is equal to 1. So we get an whole number, that is first one carbon. What's the whole number here? 6. For hydrogen, the whole number is 6. And oxygen, the whole number is 1. Am I right? 1. So we get one value. Am I right? So we can say which are the elements here? Carbon, hydrogen and oxygen. Am I right? 3 elements. Here how much carbon we get? How much carbon? What is the whole number here? 6. So we can write as C6. Hydrogen how much here? 6. C6, H6, oxygen 1. So what is our formula? C6, H6, O. So what is the empirical formula here? C6, H6, O. Here empirical formula is equal to C6, H6, O. Now empirical formula is represented as N, a small n. N is equal to one formula, molar mass divided by calculated empirical formula mass. Molar mass divided by calculated empirical formula mass. Okay, here we know molar mass is equal to 2 into vapor density. What is about the molar mass formula? Molar mass is equal to 2 into vapor density. So I am writing here that is equal to 2 into vapor density divided by calculated empirical formula mass. So what is our calculated empirical formula mass? That you have to calculate. How can you calculate? Means one carbon, the atomic mass is 12. Am I right? One carbon, the atomic mass is 12. Am I right? So 12 into, how much carbon is there? 6 carbon. So 12 into 6 is equal to, what is 12 into 6? 6 2s are 12, 1, 1, 6, 72. We get the 72. Am I right? Next, how much? Next element, hydrogen is there, 6. One hydrogen, one value. So how much hydrogen? 6. So 1 into 6 is equal to 6. Am I right? Next, oxygen. Here oxygen, we know that one. Oxygen is 16. Am I right? 16. How much oxygen is there? 1 oxygen. So 1 into 16. Am I right? So what is the answer? 16. So we have to add now. 6 plus 6, 12. 12 plus 2, 14. So 4, 1. 7 plus 1, 8. 8 plus 1, 9. 94. So we get the value is 94. Calculated empirical formula mass is equal to 94. Okay. So 2 into vapor density. Already the formula. So the vapor density is also given in our question. Once again, please all of you read the question. Calculate the empirical and molecular formula of a compound containing 76.6% carbon, 6.38% hydrogen and rest oxygen its vapor density is 47. That is also given. Am I right? That is also given. Okay, so the vapor density value is also given. So we can written as that is equal to 2 into 47 divided by 94. So, okay, that is equal to 2 into 47. 2 into 47 is also 94. Just you are multiplying, we get 94 divided by 94. 94 divided by 94 is equal to how much? 1. So, we get the value is 1. So, n value, we find out the n value, 94 divided by 94 is equal to 1. So, n is equal to what is the value? N is equal to 1. Here, it's a molecular formula. Molecular formula, we can be written as molecular formula. Molecular formula is equal to n into empirical formula. So, molecular formula is equal to, here, what is n here? Now only find out what is the value of n? 1 into empirical formula. Empirical formula already we written. What is the formula here? C6H6O. Am I right? C6H6O. So, what is here? What is the molecular formula? Molecular formula is equal to C6H6O. Okay, this is the first problem. Am I right? Next one. Second one. Question number 43. Please all of you take the question number 43. A compound on analysis give sodium. Na means sodium. Sodium is equal to 14.31%. 14.31%. Sulfur is equal to 9.97%. Hydrogen is equal to 6.22%. And oxygen is equal to 69.5%. Calculate the molecular formula of the compound if all the hydrogen in the compound is present in combination with oxygen as water of crystallization. Molecular mass of the compound is 322. This is a given. Dear children, here also, for this question also we are making one tabular column. One tabular column. First column I am writing element. As per this question, we have 4 elements. One is sodium. We have to write the element. Sodium. Symbol of sodium is Na. Second element is sulfur. 9.97%. Next element is hydrogen. 6.22%. Next one is an oxygen. 9.5%. Okay. Next, we have to write the percentage also. What's the percentage of sodium? 14.31%. Sulfur percentage 9.97%. Hydrogen, what is the hydrogen percentage? 6.22%. What's about the oxygen percentage? 69.5%. Okay, here we have to write next to one tabular column. Relative number of atoms. Relative number of atoms. Relative number of atoms. Previous 42, question number 42 also I explained about that. Relative number of atoms. How will you write the relative number of atoms? Relative number of atoms, percentage divided by atomic mass. Percentage. Which percentage is given, that divided by which element atomic number. Okay, here sodium percentage is given as 14.31 divided by atomic mass of sodium is 23. What is atomic mass of sodium? 23. So just we are dividing, we get the approximately value 0.62. What's the value here? 0.62. Next one, sulfur. What is the percentage of sulfur given here? 9.97 divided by, what is the sulfur atomic mass? 32. Okay, 32. That is approximately equal to 0.31. 0.31. Next one, hydrogen. Hydrogen, what is the percentage of hydrogen given? 6.22 divided by atomic mass of hydrogen. All of you know that one. That's same answer we get, 6.22. Am I right? Oxygen, what is the percentage of oxygen here? 69.5. 69.5. What is the atomic mass of oxygen? 16. Okay. Those who are feeling any doubt now, please discuss. Please check it that on that class table. Already I said that page number 56, 57. Okay, 56, 57. Sodium. Everything here having sodium. When you are checking here, you know. Page number 58, 59. Those who have the class table, please all of you take it that one. Atomic number of sodium, all of you know that one, 11. Maximum, if you are writing now, we get the double. Page number 56. Everything having here. Next element, sulfur. Sulfur is also here. Page number 59. Sulfur 32.06 like that. We have to take 30, round up, we are getting 32. Next, hydrogen, all of you know that one. Oxygen. Oxygen is also page number 58. Please check it that one. 16.0. So all the values are given. Almost, at least we have to check it. Okay, please. Next. So related number we written. Next we have to take the symbol ratio. The last column is symbol ratio. Here what is the symbol ratio? I already told that. Symbol ratio. How will you take the symbol ratio? Which one have the low value? As per this tabular column, sodium 0.62, sulfur 0.31, hydrogen 6.22, and oxygen 4.32. Am I right? Out of this, so sulfur is the least value, 0.31. So we can take that value, least value. First one, sodium 0.62 divided by 0.31. So just we are dividing, approximately we get the values 2. Next one, sulfur 0.31. The least value is also 0.31. So approximately we get the values 1. Same value. Next one, hydrogen. The given value symbol ratio is 6.22. The least value is 0.31. Just if you are dividing now, we get the value is 20 like that, approximately 20. Please divide and find out the answer. Next, oxygen. Oxygen is 4.34. Just we are dividing by the least value 0.31. We get the approximate value is 14. Am I right? So next, now we can take the empirical formula. Empirical formula now. How much sodium is there, that you have to find out. Here the symbol of sodium is Na. The symbol ratio, we get the sodium value, symbol ratio is 2. Am I right? So we can be written as Na2. Okay, symbol ratio, we get the value for sodium is 2. Next one is sulfur. sulfur simple ratio we get simple ratio is 1. Hydrogen, next element is hydrogen, H. Here hydrogen we get the simple ratio value is 20. Next oxygen, symbol of oxygen is O. Here simple ratio value we get 14. So what is the empirical formula we get? Na2 yes H20 oxygen O14. So empirical formula is represented as here N is equal to N molar mass divided by calculated empirical formula mass. Molar mass divided by calculated empirical formula mass, that is equal to molar mass, that is already given the compound, this total compound, entire total compound, the molar mass is given, that is 322. Am I right? Here molar mass of the compound already they given 322 divided by calculated empirical formula mass. Okay. Here this calculated empirical molar mass we have to calculate. Here the element is Na2SH20O14. Here how much sodium is there? 2 sodium. So 2 sodium, all of you know the atomic mass of sodium is equal to 23. So 2 into 23 plus sulfur atomic mass is 32. How much sulfur is there? 1 sulfur. So 1 into 32 plus here hydrogen is 1. Atomic mass of hydrogen is 1. Here total 20 hydrogen is there. 1 into 20 plus oxygen. 1 oxygen is 16. Here 14 oxygen having 14 into 16. So next we have to write 2 into 23 is equal to 2 into 23. What is the answer? 2 into 23 46 plus 1 into 32 is equal to 32 plus 1 into 20 is equal to 20 plus 14 into 16 24 6 4 so 24 2 6 it's 84 4 1 so we get 4 12 224. Am I right? So we get plus 224. So what is the answer? Just if you are adding, we get the approximately, we get the value is 322. What is the answer here? 322. Okay. So the molecular formula. What is the molecular formula of this compound here? Na2SH20O14. Okay. Here molecular formula. Here Na2SH20O14. This formula can be written as, we can be changed it and write here sodium, Na2, sodium sulfate. What is the formula for sodium sulfate? Na2SO4. Na2SO4, sodium sulfate with 10 molecules of water. 10 molecules of water. We can be written as Na2SO4, 10 molecules of water. Okay, so what is the molecular formula here? Molecular formula of this compound is, what is the molecular formula? Sodium sulfate, that is Na2SO4 10H2O. Okay, okay, my dear children, try to learn this question number 42 and 43. Okay, after learning, everyone, all of you learn this question. Okay, and write in the assignment note. Okay, and I will check your note, all of you. Don't forget that one. I will check your note. Try to learn and write. Okay. If you have any doubt, please ask me. Okay. Thank you all of you. Thank you. Have a nice day.